Welcome to this explainer. Look, I have spent years guiding business analysts, and if you are stepping into a role where your main goal is to solve real-world problems with data, you are exactly where you need to be. Today, I'm going to walk you through a highly functional, project-driven approach to solving massive business challenges using machine learning.
So let's just tackle the elephant in the room right off the bat. How do we actually do this? How are we supposed to predict customer churn or optimize retail pricing without needing a PhD in computer science? Well, here is the secret. You absolutely do not need to be a software engineer to leverage the power of AI. You just need a structured framework. So today, we are focusing entirely on function over deep technical coding.
Think of today's lesson plan as a set of modular building blocks. We're going to cover 1. Defining the business problem, 2. The ML workflow, 3. Preparing and cleaning data, 4. Choosing your AI tool, and 5. Interpreting feature importance. Okay, let's dive right into section 1, defining the business problem. Start with the goal. Listen, before you ever touch a data set or write a single line of SQL, we have to strictly define the business objective and set our boundaries. Think about our first real-world case study, retail product pricing. Say you're in charge of marketing for an umbrella company, right? And the big business goal is to increase sales by dropping the price. Can you predict how many umbrellas you'll actually sell? It's wild how that single objective just explodes into multiple data requirements. Aside from historical selling price, suddenly you need weather data to track rainy seasons, geolocation data, population density, and even supply chain inventory data just to see if you can meet that new demand. Now, what's really fascinating is how the exact same logic applies to a completely different industry, like telecommunications. Here, our second case study is predicting customer churn, when a customer just cancels their subscription. The business question dictates exactly which discrete data sources we need to gather. We map the problem to specific branches of data, like customer tenure, their billing history, and service data. The goal literally dictates the data collection. Moving right along to section 2, the ML workflow, the operational blocks. With our problem clearly defined, we move into the actual execution pipeline. Now, the enterprise ML workflow is not a straight line. Not at all. It is a complete 10-step loop. Your data collection feeds right into data processing, which flows into modeling, then testing, and eventually deploying and maintaining the model. Because once a model is live and capturing new data, well, that data feeds right back into the pipeline to start the cycle all over again. But honestly, to make this much easier to manage for your projects, I want you to mentally condense those 10 steps down into just 4 functional phases. Think of these as your core project management blocks. Phase 1 is decision-making. Phase 2 is data processing, Phase 3 is modeling, and Phase 4 is deployment. That brings us to section 3, preparing and cleaning data, also known as doing the dirty work. Because as an analyst, you have to know that the quality of your predictive model relies entirely on the quality of your data set. Garbage in, garbage out, for sure.
Think about a before and after comparison of your data. Initially, you have raw, messy business data. We're talking missing values, strange characters, a total mix of text and numbers. But to get ML-ready data, we absolutely have to transform that raw mess into a strictly numerical format with meaningful magnitudes. An algorithm just cannot process it otherwise.
So here is your essential data cleaning checklist. First up, handle any missing or anomalous values. Second, drop irrelevant intermediate columns that don't actually predict anything, like a randomly assigned customer ID. Third, remember that machine learning algorithms need numbers, not words, so you must translate string categories using a technique called one-hot encoding. And finally, scale your numeric features to a standardized range, typically 0 to 1. That way, everything fits properly without skewing the model. Once that data is spotless, you are ready for section 4, choosing your AI tool, finding the right fit. You need to select the right framework to build the model, and that's based on your team's technical comfort and your project's timeline. So choose your path using this simple rubric. Use no-code solutions like AutoML for fast prototyping and quick experiments, because the system does the heavy lifting of feature engineering for you. Use low-code frameworks like BigQuery ML if you want moderate control and you already have strong SQL skills. And reserve custom code using Python libraries like scikit-learn or Keras for when you absolutely need full, deep customization. Say you choose the AutoML route, the interface is incredibly visual and approachable. You just simply select a tabular objective based on your business problem. So, if you're solving our telecom churn problem, you'd select classification because we are sorting customers into 2 discrete classes, churn yes
or churn no. It really is that straightforward.
Which brings us to our final core topic, Section 5, Interpreting Feature Importance, Driving Insights. Look, training the model isn't the end of your job. In fact, it's just the beginning of where you provide real value. You have to act as the translator to your business stakeholders by explaining exactly how the model's making its predictions.
Using something called the sampled Shapley method, we can literally pinpoint exactly which data features had the strongest correlation and impact on the model's training. In a typical energy usage example, things like average kilowatt hours and total customers might heavily impact the prediction, while zip code barely registers. This tells the business exactly where to focus their strategy. You can also use a correlation heat map during your initial data analysis to visually spot which variables move together. Basically, the brighter the color, the stronger the relationship. This helps you flag any patterns that might be highly predictive or completely nonsensical. Like, if your model says the distance of a taxi ride is the least important factor in predicting the fare, you know you have a massive problem to debug.
I always tell my junior analysts to remember this. A model is only valuable if you can extract its insights to drive an intelligent, functional business strategy. It is not just about getting a high accuracy score. It's about making absolutely sure the model has learned actionable, real-world patterns that your company can trust and act upon.
Well, we have definitely covered a lot of ground today, from strictly defining your business objective, all the way to cleaning data, choosing your framework, and interpreting the final insights. Now that you have the functional playbook, the ball is entirely in your court. The algorithms are built, but the business strategy is yours to shape. So what real-world problem are you going to define, clean, and solve first? Thanks so much for joining me on this explainer, and I really can't wait to see what you build.